Block 1. The Woman Who Unveiled the Invisible Universe. Hello everyone, and welcome back to the channel. Today, we're delving into one of the most significant, yet often overlooked, injustices in the history of science, the story of Vera Rubin. Her name might not be as instantly recognizable as Einstein or Newton, but her discoveries fundamentally cracked open our understanding of the cosmos, revealing that the universe we see is just the tip of a vast, invisible iceberg. Born in 1928, Vera was captivated by the stars from a very young age. While other children played, she would lie awake, mesmerized by the celestial ballet outside her bedroom window in Washington, D.C. Her father, an electrical engineer, nurtured this passion, helping her build her first rudimentary telescope and taking her to amateur astronomy meetings. This early encouragement was crucial because the path she chose was one not just of scientific inquiry, but of relentless struggle against the institutional biases of her time. When she applied to Princeton's prestigious graduate program in astronomy, she was bluntly informed they did not accept women, a policy that wouldn't change until 1975. Undeterred, she pursued her studies elsewhere, earning her master's at Cornell and her PhD at Georgetown, all while raising a young family. Her early academic work was already shaking the foundations. Her master's thesis suggested that galaxies might be rotating around some unknown center, a controversial idea that was largely dismissed at the time. But it was in the 1960s and 70s, working at the Carnegie Institution of Washington alongside instrument maker Kent Ford, that she would make the discovery that defined her legacy. The question they sought to answer seemed simple: how do galaxies spin? According to everything we understood from Newtonian and gravitational physics, the vast majority of a galaxy's mass, and therefore its gravitational pull, should be concentrated where the stars are brightest, at the center. Think of our own solar system. Mercury, closest to the sun's immense gravity, whips around at a blistering 107,000 miles per hour. Distant Neptune, on the other hand, plods along at a leisurely 12,000 miles per hour. The further you get from the central mass, the slower you should move. This is a fundamental law of gravity. So naturally, everyone expected to see the same pattern in galaxies. Stars at the luminous, dense center should be moving fast, while stars at the dim, sparse outer edges should be moving much, much slower. Using Kent Ford's incredibly sensitive spectrograph, Rubin began the painstaking process of measuring the velocities of stars and gas clouds within the Andromeda Galaxy, our closest spiral neighbor. Night after night, they pointed the telescope, captured the faint light from the galaxy's edge, and analyzed its spectrum. What they found was not just surprising, it was impossible. The data produced what is now famously known as a flat rotation curve. Instead of slowing down, the stars on the far-flung fringes of the galaxy were moving just as fast as those near the center. How could this be? It was like finding that Neptune orbited the Sun at the same speed as Mercury. It defied the laws of physics. The visible matter, the stars, gas, and dust they could see, provided nowhere near enough gravitational force to keep these speeding outer stars in their orbits. They should have been flung off into the cosmic void millions of years ago. The implication was staggering, and Vera Rubin did not shy away from it. There had to be something else there. Something massive, unseen, and spread throughout the galaxy in a vast spherical halo. This invisible substance was exerting the gravitational force necessary to hold the galaxy together. She called it dark matter. Her meticulous, undeniable observational data provided the most compelling evidence that our universe was dominated by a substance we couldn't see, detect, or comprehend. Subsequent studies of other galaxies confirmed her findings again and again. It wasn't an anomaly, it was the rule. Today, it's estimated that this mysterious substance makes up a staggering 85% of the universe's matter. Vera Rubin's work didn't just add a new chapter to astronomy, it revealed that the book we'd been reading was missing most of its pages. Her observations created an entire new field of cosmology dedicated to finding this dark matter halo. Yet, despite this monumental contribution, the Nobel Prize never came. The prize for work related to cosmology and the universe's structure was awarded multiple times during her lifetime, often to male theorists whose work was either built upon her observational proof or ran parallel to it. She passed away in 2016, making her ineligible for the award posthumously. Her legacy is a powerful reminder that the universe is far stranger than we can see, and that true discovery often comes from those who dare to question everything. What are your thoughts on Vera Rubin's incredible legacy and the recognition she deserved? Share your comments below. Subscribe for more untold stories, and see you soon.